Hello and welcome to another video. In this video we're going to be working on divide array into arrays with max difference. And in the problem you're given an integer array nums of size n and a positive integer k. And you want to divide the array into one or more arrays of size 3 satisfying the following conditions. Each element of nums should be in exactly one array, and the difference between any two elements in one array is less than or equal to k. Return a 2D array containing all the arrays. If it's impossible to satisfy these conditions, return an empty array. And if there's multiple answers, return any one of them. So they kind of show you here, and this kind of hints at what you need to be doing. So you can see that like, this is sorted, and this can't happen because of the 7. So basically, if you want elements that are the closest to each other as possible, right, to satisfy this second thing, the first thing is pretty easy, right? We just put each element in one array, but to satisfy the second thing, you basically want to take a sorted array and put elements that are closest to each other in the array. So for example here, because we have to have 1 in a chunk of 3, what are the numbers that are going to be closest to 1? Well, it's going to be the numbers that are right next to it, right, in a sorted fashion. So because that's the case, then we know 1 wants to have this. And then, like, what are the elements that we want to have with 8? Well, because we know that 1 has to have these, then the same kind of thing with the next element, right? So this is a sorted array. So if 1 has these, then this is basically done, and then you have this left over, and then it's like, okay, well, for this 3, what are the best elements to pick that are closest to it? Well, it's going to be the elements right next to it. And then for this 7, and so on. So essentially, you can basically just figure out you want a greedy approach here. So really, all you need to do, it's honestly kind of close to an easy problem once you figure out a greedy approach works. You just sort the array, and you always just split the array up into chunks of 3 because you want the elements that are right next to each other to be in the same array. And then you just check for each chunk, are the elements in the range k. So you just check, like, is the first and the last element, are they k apart? And if they're not, then like those are going to be the farthest elements apart, right? Because it's going to be a chunk 3 in increasing order. So we're going to have numbers, you know, like 6, 9, 10 or something. So the two farthest elements are going to be the first and the last. You just check, are these k apart? If they're not, then you can't have a solution. So you just go chunk by chunk, make a chunk, and make sure that this follows. And then you just put your items in the array, and that's pretty much it. So yeah, I think the main thing is just to figure out that greedy is the best. And they do kind of give this to you from this example, that greedy is always going to be the best thing to do. So we can code that up. So essentially, we're going to sort these numbers, and we basically need to divide it into chunks now. So we can just have a result, and we're going to loop through and get a chunk at a time. So we'll say for I in range 0 length nums, and we want each chunk to go up by 3 elements, so we'll have a step of 3. And we're just going to get a chunk, so the chunk will be nums I to I plus 3, right? Chunk of 3 elements. Now we just check, is the first and last element, are those elements k apart or less? So if nums, or if chunk -1 minus chunk 0 is less than or equal to k, that means this chunk is valid, so we'll put our chunk into the array and we just keep going. So result append chunk else, return the empty array. I think you want to return the empty array if this isn't doable. So finally at the end you just return result. And let's take a look and submit. And there we go. So pretty good. Yeah, and basically as soon as you realize, so they also give you a hint from the constraints. You know, you need a linear solution or like n log n or something. So as long as you realize like the way to make the chunks that are closest to each other is just pick elements that are in increasing order, then it's a really easy one. And time here is n log n, and the space is O of 1. Because even though we do use a chunk of 3 elements, the result doesn't count for the space, so this chunk is constant space. So now we have O1 space. And yeah, hopefully this was helpful. If you have any questions about like kind of more in depth how I did the greedy, like why, basically just draw out the array and it's pretty easy to figure out. And the example also kind of tells you that. So you can try like maybe doing a non-greedy way and see the issues with that. So yeah, if this is helpful, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.